Hello, this is Colin Wilson from Oxford University. Welcome to Hawaii. Today we're driving up to the top of Mauna Kea, which is the highest volcano in Hawaii. Because the weather's good here, the skies are exceptionally clear, this is where many of the world's top telescopes are built. Today we'll be using the Canada-France-Hawaii telescope, CFHT, which is just at the end of the road here.
And then hold it till I say stop.
Okay, it is labeled.
We're using the CFHT today to observe Venus, our closest planetary neighbour. We're now in the control room. You can see the banks of monitors and TV screens around you, and we're going to go into the telescope shortly.
Move it down.
Okay, go ahead.
We're now swiveling the dome around so that not only the telescope but also the slit in the dome is pointed at Venus. Today we'll be using the CFHT to measure wind speeds on Venus. This shot's really confusing because it's not the telescope which is rotating, it's actually the dome which is rotating, and you, the camera, are moving with the dome. We're now at another telescope, only 500 meters away from the CFHT. This one's called the NASA Infrared Telescope Facility. We're using this at the same time as the CFHT, but we're measuring sulfur dioxide abundances. Now, sulfur dioxide is a gas which is emitted from volcanoes, so the detection of large and variable amounts of this gas on Venus might be a clue to active volcanism on Venus. Approaching Venus from space, you don't see much. You would only see this incredibly bright white cloud layer. That's the sulfuric acid clouds. But we can use radar to see through the cloud. And that reveals quite an Earth-like landscape in many respects. You have highlands and lowlands and rifts and lots of volcanoes. If we were to stand on the surface of Venus, we could imagine it would look very much like this volcanic landscape in Hawaii where we are, except that when you look up, you'd see the sky is a yellow-orange color because of the sulfuric acid cloud layer. When you look around, some of the volcanoes might be active. We're seeing signs of that. Remember, the temperature at the surface is 450, 460 degrees centigrade, far hotter than a kitchen oven, for example. And the pressure is quite high, and it makes the visibility quite poor as if you're at the bottom of the ocean. It's quite an environment, isn't it?